know had said 2.5. I don't
Okay.
know if they still want to comment, but just to say that Michaela was the person. But maybe by now she would have changed her answer. So she could raise her hand if she still wants to say something, or we can just move along. It's your choice,
No,
Mrs.
I
Smith.
want to big up this Jean Adam Smith, if I'm calling the name correctly. This student said 8 in one, 8 in another, and 9 in another. And so the combinations can vary as long as the total eggs we have is 25. All right, so great job, students.
And
Great
that
job.
is because the question did not say it needs to be equal amount.
Evenly distributed. All right.
A
And
quick one here, Miss
go ahead.
Cameron.
Yes.
I'm seeing where Geneva put in the chat that 12 eggs in one and 13 in the other. I would love for you to address this.
All right, so to go again and speak of the extra one, we are only allowed, so the constraint for each container is 12. And so because we are looking at that in the question, we already know that only 12 eggs can go into a container, so we can't have 13. And so we recognize, so you would still have, so what that student is saying, they would go back to only 2 containers, and we would have explained that we needed a 3rd container. So where we're at now, we're staggering. We're trying to see what would be a good combination, because Mr. Hamilton earlier had asked the question if it made sense to have only 1 egg in the 3rd container. And so we moved from that discussion to say, how else could we, since the question didn't ask us to evenly distribute the eggs, how else we could have placed the eggs in containers? And we got a few responses. I remember just speaking about Adam, the young man, who gave us 8 in one container, 8 in another container, and 9 in another container. One, the containers will be wouldn't be too light to carry, and so it could be distributed in that order. And that wasn't the only combination. I think someone said 12 in one, 6 in another, and 7 in another container, still giving us the total eggs that we're working with. And so students, just by taking that one question, or it brings us back to the point, if we were able to draw, we could have modeled the containers and placed our circles in the containers. So when we're doing our performance tasks, modeling is very good. It helps to see how you're thinking and being precise. Remember, now we're asking you to make sure that whatever situation you're getting, if they're talking to you about persons traveling in a bus, same situation could have been a bus. I could have said to you, Mrs. taking the class to Hope Gardens is 25 students, including the teacher. How many bus? The bus is a 12-seater bus. How many bus would we need? And we could not say, and I know some of you would say, Miss, sit down in a lap and all of that. But we don't want any tickets. We know that everybody have to sit in one seat. So based on the constraints, again, we have to make sure that we are precise in an accurate, right? We are looking for efficiency. So when it comes on to the task, students, we're saying, make sure that when you're solving the problem, it is clear, your ideas are clear, and you're very precise. All right, we spent a long time with this practice, so we're moving on to the final 2 practices. And so
Mrs.
this,
Edwards,
yes, go ahead, Mrs.
as
Darby.
you are moving along, this public service announcement
Yes.
that the workshop is now being streamed live on YouTube, and the link is in the chat. So I will ask that Mr. Lee has reposted the link in the chat. Thank you for that. So if you know anyone who would like to come on, could you just tell them that they could also view on YouTube. Thank you very much. And thanks for the person who reached out in the chat to ask about that.
The YouTube, all right, not a problem. So the math practice 7 now speaks to looking for and make use of structure, patterns. So I can see and understand how numbers and spaces are organized and put together in terms of parts and whole. Students, sometimes you may have multiplications and you're multiplying numbers. And here we're seeing an example with the area model, and we're looking at 13 multiplied by 15. Now, I might not have used this strategy in terms of breaking apart the 10 and the 3 and the 15 to get, so we have 10 and the 3 and we have 10 and 15. But I love this because when I'm doing multiplication, if I'm actually doing a multiplication based on pattern and based on the distributive law, I usually break one of the numbers. I would break 15 to be 10 and 5, and I can easily multiply 10 by 13 and then 5 by 13, or 13 by 10 and then 13 by 5. When we look for patterns, when we look for structure, it gives us this ease. It gives us the opportunity to move beyond procedure, just trying to follow a rule, and you see the reasonableness and you see the fluidness of math. And so teachers, when they go through the tasks, help them to look for patterns when they're operating with numbers. Sometimes the base 10 structure will help us. And so math practice 7 is simply saying, try to understand and look for structure in how we do the problem. And most of us, if we were to think about a problem, after a while, we begin to look for patterns. Most times we operate in that space. And not just numbers alone, we can look at shapes. After a while, we can identify what the dimensions look like. We have an idea about certain attributes, how things can rotate or reflect. All of these things help us when we are solving math problems. And so the 8 practices that we're sharing with you today, students and teachers, is to help them with understanding the task, making sense of the problem, persevere, and try to solve it and give the correct answers. Now, the final practice speaks about having look for structure. So we have looked for structure, and so we begin to see repeat calculations. Okay, I've seen Miss do this before. Miss, I get a pattern. Miss, I can see a shorter way to do it. Don't always jump to shortcuts. We can always get to shortcuts later. So math practice 8 speaks about looking for and expressing regularity in your repeat reasoning. And so here we have an example. It says, I have a container of yogurt, which is 3/4 full. Okay, Facey, I see your hand. I'm going to allow you to miss. A hand is raised. We're going to hear what the student has to say, or if it's a question being asked. So I have a container of yogurt that is 3/4 full. Now, 1 serving of yogurt is 1/4 of the container. How many servings are left in the container? And what I loved here is that the student decided to model. Many times we see something like this, students, and we begin to just do some calculations. We begin to say, I'm going to divide and I'm going to follow some procedure, or we jumped and we say, okay, if it's 3/4, we start to say, I'm going to divide that in 1/4 and so forth. But look how beautiful the rectangle has been divided, and we can see the 1/4, we can see the half, we can see the 3/4, and right then and there you can say, okay, this is 1 serving, 2 serving, 3 serving. And so when you notice patterns, we are saying to you, after you have done this, and modeling can come into how you're looking at your generalization, and then you can always go back and check using a regular algorithm. All right, so notice it says, so after the rectangle was used, you notice that in the latter part, it says, once I understand that division of fraction can be used as a shortcut, you can go ahead and divide. A lot of times the students struggling with to say, why do I need to change division to multiplication and invert fractions, all of that. So many rules to remember. However, when they are modeling or when they are looking for regularity and they are getting to the point where they can come up with a generalized statement, it's always good to start from an area where they can visualize it. Okay, I see the hands. Go ahead and unmute. What's your question? Mrs. Williams, go
Dante
ahead.
Facey, please unmute. All right, Dante. All right, so moving on to Geneva. Geneva, you may unmute, please.
Miss, like
Yes.
the bottom one that said one, I understand the question. So it shows are those example or just the answer?
The working.
The working out. So they give the answer as the final part, which is the answer is 3.
Yes. So how would you have calculated? How would you have worked this question? The question says, I have a container that is 3/4 full. Now, 1 serving of yogurt is 1/4 of the container. How many servings are left in the container? How would you answer this question?
Miss,
Yes.
I would like divide.
You will divide. So you do like what is down at the bottom.
Yes.
Okay. All right. And nothing is wrong with that because that's what you're comfortable with. But you notice that one student right here, where is my pointer? I don't have a pointer. I can point on.
Mrs. Cameron Edwards.
Yes, go ahead.
Let me just say this quickly. You might be able to do your own drawing. If you tap on your tracking pad there, just tap with 2 fingers and you will see a number of things coming up. Just be very gentle. You'll just see a window pop up asking you to select pointer along with a number of things.
Okay, it's
presented to
down
you.
here. I'm seeing it now. Beautiful.
You can select yes, excellent.
Thank you.
There
All
you
right.
go.
So thank you very much. All right. So let me go again, tap and see if I can actually draw. Let me be gentle about the tap. Let's tap gentle. And then let's
And
take
select
a
pen.
pen. Awesome. Thank you very much. All right. So students, Miss just said she would do the last operation and nothing is wrong with her way of thinking. She's just doing a regular computation, the algorithm. She's showing that 3/4 divided by 1/4. She would change the division to multiplication. She would invert the fraction and proceed until she gets the 3. However, another student would write, I can notice that 1/4 is repeated and draw a model to figure out the number of servings left in the container. Now, please look. This is what is one student's method of doing the problem. Can we understand the 3 servings here? Yes, we can. And we can see what is left in the container. So all we're saying is we all will answer the question differently. So when you're doing the problem, so as you work, you must think about what you're trying to figure out. Pay attention to details. And when you're through, you evaluate your results to see whether or not is reasonable. All right? That's all we are saying today in terms of the practices. All right? We have spent we are where we want to be. We need to spend an hour on the task, and I have 2 more slides before we get to the task. All right, so those hands can come again when we get to later down in the presentation. Thank you very much for the student that unmute and shared her thinking. Okay, I'm so far back. And why is this?
All right, I see you're moving. Excellent.
All right, so let's go right back here. All right, so we're right back where we are. All right, so students, this is your second round in doing PEP. You would have done something in grade 4 last year, I believe. Now, we all know that PEP is measured by the following domains. PEP is basically going to look at, test you on the topic, the concepts, the procedures, the things that Miss or Cert is teaching in class. So it's not going to be anything that the teachers didn't teach you. It must be about something where the teacher didn't teach you, right? So just relax. And of course, we know it's going to have some kind of problems in there. And we're going to start going through the process. And in the slides after this, we're going to take you through a few problem-solving tasks or strategies, rather. All right, we spent a long time a while ago about modeling to say that, listen, students, they're going to want you to model something. You can model using a diagram, you can model using a number line. They're expecting, if it's even an equation, some kind of expression, number, sentence, they expect you to model and even analyze some data. Students, you must communicate. Communicate your thinking. It means that you're going to write on the paper what you're thinking. Your communication may also be supported by models, not a problem, but we are expected to. So these are the 4 domains that is measured by PEP. It must be about a topic that Sir or Miss covered in class, something that they teach, some concept or some working or some procedure. It's going to be problem-based. And so we're saying, make sense of the problem, persevere, be precise, look for patterns, model. All right? Now, as we prepare ourselves for these problems, we must understand what the problem is saying, and I'm going to be asking you these questions as we go into the task. Understand the problem. You're to devise a plan. Needs a plan in your head in the 5 minutes, so read the question and make a plan. How are you going to work this question? What are they asking me about? You're going to carry out the plan, look back, now say, okay, I'm finish and it right, check, and then you do the cycle. If you feel as though your answer is off and you feel like, okay, I'm getting some weird numbers, you know, sometimes you're doing a problem and you're sure you're not supposed to be getting some numbers that is so way off, some decimals or some way off numbers, and you have that feeling, you look back, you might have missed a step. Instead of adding, you might have multiplied. Instead of multiplied, you might have divided. So you check, and then you go right through until you'll have solved the problem. So here are some problem-solving strategies for you today. We have 8 of them. The first one is, it's math, so you must be doing an operation. So choose an operation. What am I going to be doing? Do I need to add? Am I going to subtract? Am I going to multiply? Am I going to divide? Choose one. Then you apply it. Do I need to draw a diagram? Am I going to do some connections? Am I going to expect it to model? Even if they don't ask you to model, some students, the best way for them to do something is modeling, right? So it's not always running to the regular algorithm or the procedure. We spoke about finding patterns in the previous 2 slides, all right? So looking for the regularity, looking for structure. So, okay, I'm seeing a triangle. Suppose I'm creating a design. And they say to you, use these shapes and to create a design for a gate. You're expected to have a triangle. What you notice about the triangle is blue. What you notice about the rectangle, if it's a square or so, it's yellow. We see a circle, it's purple. We see the heart and it's red. And so if I'm going to be coloring something, I don't expect to see the rectangle or the triangle in purple or in red. So you follow the pattern. So you find the pattern and you follow the pattern and so forth. Sometimes you have to make a checklist. And so we have a bit of a checklist, but checklist as to what information is given in the problem. Sometimes in the problems, you have to underline what information. Okay, so I'm going to do this. I have 20 in there, or I have 25 eggs, 2 containers, or 25 eggs, 12 eggs can hold in 1 container. So you start to underline the math in the information. It's your paper, so take your time and look at what is required. Sometimes you're required to work back way. There are several students who can tell you the answer, but then they say to you, Miss, I don't know how to tell you how I get the answer, but Miss, this is the answer. So students, you have to find a way. If you get the answer by looking at the problem, because some students are like that. They can't put it on paper, but guess what? The examiners don't know you. you're coded. They're just going to pick up a paper. They don't know you. And so they can't come to you and say, Javon, what was the, I see that your answer is right. And say, yes, man, Javon is going to, I know that Javon work it in his head. And no, students, they have to show them how, back way, show them how you figured it out, all right? So there are some persons who can work back way, and that's also a strategy. One of my favorites is making a table. It's not the only one, but I tend to like the table because it will help me to organize my information a little bit better. Guess and check. Remember now with guessing, you have to check. Because sometimes we guess, I will say, yes, man. But then we try it again with another scenario and it don't work. So you see, when you're guessing, you have to make sure you check. And if you realize on your check that this is not going to work for everything, then you realize that it was just a buck up. Sometimes we guess and we have a little buck up, and then we say, okay, this means that this is the rule, but it's not the rule. They never checked it. And so when you check it, you realize that what you said cannot work for everything. Because in practice 8, it says after you have looked at the structure and you come with a generalized statement, the generalized statement must work for every single thing. And the final one is to use logics. Sometimes too, you have to use a bit of logics in terms of looking at what is given and what you don't know and logically put it together. So these are the 8 strategies. Now, I'm sure there is at least one strategy here that you would have used before when you're solving problems, all right? But let's see. We're going to explore using these strategies. We're going to give it a problem, and you're going to tell us which strategy you would use. Now, final thing as we go into the task, this strategy teaches our students is called 3 reads. Now, the 3 read strategy protocol is one way to do a close read of a complex problem. Students are going to get a problem. You're going to have a whole heap of words. So it'll look complex to you, right? However, you can have ways in which you can tear it apart. So this strategy really includes reading the math scenario 3 times. How many times? 1 time, then 2 times, then 3 times. Some people might say, why I want to read the same thing over and over and over? Because you see, the first time when you read it, your eyes just gloss over it. Your eyes just are run on with the words. So the second time you're reading it, you start to say, okay, all right, I see a hand up. Are you explaining why you think it's good to read 3 times? All right, I'll allow somebody to unmute now. All right, I see some hands going up.
Javier,
Go ahead,
please unmute.
Javier.
Miss, why I think you should read over 3 times, because you might see a question you don't understand and you might have to read over and over to get the concept.
All right, so you need to read over until you get some understanding of the task. Excellent. I'll be able to take one more hand, because remember the problem coming in now, and you are going to be the one working the problems and telling us how you work the problem. Go ahead.
So
You can take one.
Shahira Thomas.
Go ahead, Shahira.
Okay, good morning, Miss. I'm just asking you a question.
Go ahead.
When is the class going to be over? And yes, I understand everything and I'm doing well. Just asking, when is the class going to be over? Is it 2:30 or 1:30? Because yesterday, Miss Berry said she didn't know what time it was going to end. So I'm just asking you this.
Okay, Miss Thomas, we're not going into your lunchtime. We're going to end before the lunchtime. Okay?
Okay.
And so we'll take Geneva's comment.
All right, Geneva. Okay. Geneva's gonna talk, or we can continue.
Miss,
Go ahead.
like, Miss, is the first time when you're reading, Miss, you're not going to like get it. Your mind like going to be blank. But the second time you read it, you might get like a catch up. But the third time you read it, you might get the fully understanding.
All right. So the goal is to read it first to understand the context. Context meaning what is the scenario about? Not the math part to work it now. You just try to understand the context. Is it a class party? Am I going on a trip? Am I building a doghouse? So you read so you understand the context of the scenario. Because each time you read it, you read with a different goal in mind. All right, students? The next one, the second time you read is to understand the math. What math? So it's the same egg problem I'm going to. So the context in the earlier question was we needed to package 25 eggs. What do you understand in the math? As a container that can only hold 12 and you start doing what operation? So even in that problem, we could use an operation to help us to divide, to subtract 12 and so forth. So you read the second time to understand the math. And the third time, you read it so that it elicits the inquiry question. So what would I do with one egg? Would I put it up on the top? Would I put it in an extra bag? Is the extra bag another container? So you begin to ask yourself as you process the question and you're working students. Not taking any more hands yet. When we get to the task, I'm gonna allow you to start talking and then we write. All right, so just to summarize, 3 reads. What is the task about? Reading a second time. What question are you being asked to answer? And the third read is what important information you are given. So having done all of this, here is our task. And so I'm going to ask one person. I'm going to read the first time. And then I'm going to ask one person, if you can read it quickly, just only one person. So just raise your hand. The first person that raises your hand and you show you're comfortable. So I'm going to read. You are an executive member of your school's environmental club. One of your responsibilities includes raising funds for the club for the Labor Day Project 2023. It is the aim of the club to raise $10,000 to purchase resource materials for the school. A concert was suggested to raise the required funds. Okay, go right ahead. I think it was Miss T. Miss T?
Yes, T. Brown. Go
Miss
ahead.
T. Brown.
You are an executive member of your school environment club. One of your responsibilities include raising funds for the club for the Labor Day Project 2023. It is the aim of the club to raise $10,000 to purchase resource material for the school. A concert was suggested to raise the required funds.
Mr. Brown, don't move, don't move. My first question to you, you read it once. What is the context? What is it there? What is the problem about? What is the task about? Mr. Brown, you don't want to tell me? What is the task about? Okay, anybody else that I see them hand going up? Just one question you're answering. Based on the 3 reads, what is the task about? What is the context of this task?
So
Miss
Andrew, you're asked to unmute. Andrew?
Excuse me, Miss. First of all, my name is not Andrew, it's Aniela. It's just I couldn't rename myself.
Okay, all right,
And
Aniela.
also, I think that the task is saying, I feel like it has something to do with something about raising resource funds depending on what you're going to sell.
So you feel like the task is about raising money.
Yes.
All right, anybody else? Just one more person squeeze in quickly.
Okay. All right. Travoy. Travoy, you may unmute.
Yes, the sentence is about raising money for the school.
All right, excellent. Clap yourself. You guys did great. So clearly the task is about raising money. So students, when you see that now, you start to say, all right, how much money them give us for work with? All right, them so we must raise $10,000. So you have a ballpark figure. So you circle 10,000 and you say, all right, this is $10,000 I'm aiming to get. Okay, question continues. Need another reader.
All right. Wow. 1T, 10 Smart, please. That's 1T. Go ahead. One of the students from 1T, please read.
1T.
Yes.
Go ahead, 1T.
If not, Romario Thames. Romario Thames, go ahead.
A concert was suggested as a fundraising activity. Each concert ticket costs $100 per student and $150 per adult. The number of ticket stubs collected indicated that there were 135 persons at a concert, allowing the team to make $15,000 on tickets.
Okay,
Continue.
and go ahead.
Continue, Romario.
Continue, Romario.
Show the calculation how the team was able to earn $50,000 from ticket sales.
Awesome, excellent, you did well. Now students, using the 3-read strategy, I am asking you now, so you read the paper already and you're reading it a second time. What math information did you get here? What are the math information that you're pulling from the task? Come on, students, we have to pick it up a bit.
All
Yes.
right.
Yes, select one.
I'm seeing Joshua McWilliams. Joshua McWilliams.
Go ahead, Joshua.
Please unmute Joshua. All right, go ahead. Not hearing you, Joshua, if you're speaking. So I'm going to move over to Robert.
Go ahead, Robert.
Miss, wait a minute.
So you're answering the question, Robert, what information was given? So this is part A of the task. What information was given?
Okay, so Robert needs some time to think about it. He did say, wait, miss. Javier Harper, go ahead.
Miss, I think the key information is how much money per adult.
Okay.
And
so you are saying that
money they're supposed to go to and the amount of person coming.
all right. So the key information, Mr. Is it Harper?
Yes.
Harper said is the money per adult, but notice I didn't just stop with money per adult. I also highlighted the $100 per student. So students, you have the task. You now read the task and you're pulling on the math information. We start planning. So $100 cost for the students and $150 for the adults. He also said the number of persons attended the concert was 135. And we are aiming to make $15,000. That is the math that you're given. That is the information in the task. Now let us move on in how we're answering this question. So the information that was given, we realize that is $100 per student, $150 per adult. The number of ticket stub counted was 135, and they collected $15,000. I am now asking you, let's go down here at my little clicker and my little pen. And so, how could they have collected $15,000? I need you now to tell me how many students, how many adults went to the concert so that they could have collected $15,000. You are going to take 5 minutes, students. There's no way you could just look at this, even if it's guess and check. and give me an answer right away. So I know persons have raised their hands, and so we are trying to find out how many students and how many adults attended the concert so that they could have collected $15,000. What's the cost? $100 per student and $150 per adult. So I'm giving you 5 minutes, might need it less, but tell us your thinking. Can type in the chat. All right, so 618354, that raise your hand. 618-354. Mrs. Williams, one
Working on
student.
it.
Okay.
Go ahead. Unmute. 618354, please unmute. Okay, I do it one more time. Try again. Okay, so the person unmute and then mute it. Just tap on your unmute button once, okay? One last
All
try.
right. And then we can take somebody else and let's hear the combinations.
So I'm struggling to get that person to unmute. The person unmute and then it's muted. All right, so let's go back to the others who have raised their hands. I'll take any 618, whatever number it is, could just tell us your name. Just type it in the chat. We will make a name change for you. I see Geneva with a raise hand. Geneva?
Miss, so 65 students and 70 adults.
All right, so let's write that 65 students and 75 adults.
70.
Oh, 70. Do I have an eraser over here? What's this?
Yes, you do.
Okay, thank you.
Okay. While she's doing that, Romario, you may unmute and give your combination. Go ahead, Romario.
45 and 60.
45 students and 60 adults. Okay, all right.
And we'll ask
one more person.
Yeah, Titana Williams. Titana Williams, please unmute. Final time, Titana Williams, please unmute.
Miss, I'm not finished.
Oh, you're not finished with your number. Please, okay then, no problem. We'll take from T Brown. T Brown, unmute and give us your combination. T Brown. And we're moving quickly. If you're not with us, we're moving on.
T Brown.
All right. I'm seeing Javondre Minis. Javondre Minis. Unmute quickly, yes.
Maybe 35 and 60.
35 children or adult. Who is the 35 for Javondre? Go again, one more time.
Adults.
Minutes? Oh,
Adults.
so that's 35 adults and
60 students.
60 students.
All right, we're not going to take any more responses at this time. All right, so let's look at some constraints given. We were told the number of ticket stubs counted. So when they counted the number of ticket stubs for those persons who attend, whether it's a student or an adult, they should get 135. And so let's do some math. 60 plus 35, would that sum to give us 135? When I do this math right here, when I do some addition, I'm using the problem solving strategy operations. So 60 and 35, Mrs. Williams, please check. That's 95.
That is 95. And remember
And
to put your
so-
addition sign between both of them, 60 plus, yes.
And so this total does not go with this constraint. So I cannot work with 60 plus 35. Even if this money work out. So I wouldn't even bother work with the money right now. I'm looking at the number of ticket stubs. Let's try 45 plus 60.
That's
And that
105.
105. Again, this doesn't reach the required 135. So we have to put a little extra to this. All right, so students, remember, this is how we're planning in the exam, you know, we have to sit and plan. All right, let's look at this one. Now 65 and 60 and 70, I know is 130. And so when I add 5 to that, I get 135.
Excellent.
So 60 plus 70 looks like an option. All right, so the person who gave us that, we want to give them a round of applause. So let's now go and check to see if 60 students and 70 adults will now give us the $15,000. All right, so I'm going to erase what is not correct or we did not meet the constraints. All right, so let's go. All right, so we're looking at 60, 65, and we're going to multiply that by 100. So if you have 65, $100, how much money in that we have? Tell me, students, if I have 65, $100, quickly tell me in the chat. So 65 multiplied by 100 is what, students? Just type it in the chat. We have 2 more parts to work. What is it I'm seeing in the chat? 65
I'm
times
not
100?
seeing anything as yet.
Well, I'll be waiting. And then we're multiplying 70 times $150 for the adults.
Alia has said 6,500.
Is Alia correct, students? Are we agreeing with Alia? Anybody else agreeing with Alia? I don't want us to unmute yet. I just want us to type in the chat for this time. Soon let us unmute. Do we agree with Alia? Anybody else agreeing with Alia? I need to know if I agree with Alia before I can move.
Two other persons are agreeing, Gabrielle and Titania.
Okay, I agree too. That 65 multiplied by 100 is 6,500. What about 70 multiplied by 150? You can turn it around if you want to put the 150 at the top and multiply by 70. Doesn't matter.
So for those of you who are raising your hand, you have an opportunity to type in the chat now. So type it in the chat.
So, Mrs. Edwards, am I hearing you
Yes.
say that if I decide to put the 150 at the top and then let 70 be the multiplier, I'll get the same answer as if I had it the other way around? It doesn't matter? I think
No,
that's what I'm
miss.
hearing you saying, miss.
Yes, miss, because sometimes the student might look down and feel like, wow, multiplying by 150 is a big number. And so if they're not comfortable and they're having challenges, they can always multiply it and allow 70 to be the multiplier. And so they could turn it this way.
Okay, so it's like saying that if I'm multiplying 2 by 3, I'll get
It's
the
the
same
same
answer
thing.
if I multiply 3 by 2.
Yes, Mrs.
Okay.
Darby. Thank you.
Thank you.
And in my head, for quick maths, why I would multiply using only 2 numbers, because for easy multiplication for me, students, I don't have to go through 3 place values. I can simply go through just 2. And we know that if we multiply 0 times 150, then we will get 0. And so that would only leave me now to multiply in the 10th place, the 7 times 150. All right, so let's do the calculations. If I multiply 0 times the entire 150, we're going to get a 0. And what some teachers, what I notice they do is they put a placeholder like a 0 here to indicate that they're moving to another place, right? Just let me know that we are on the same page here. So I'm going to do that based on what I usually see. And so 7 times 0, that's 0. 7 times 5, I didn't want to calculate it until they come up with the answer. So I'll pause here and give them some more time. Did anybody type in the chat what is the 70 times 150 or the 150 multiplied by 70?
There's Javon Hamilton. Go ahead, Javon.
Miss 10,500.
So you got 10,500. So I'm going to work it out now and to see if we get the same thing. All right, so 7, we're continuing. So let me start again. 0 times 0, 0, 0 times 5. So 0 times multiplied by anything is 0. No, 7 multiplied by 0. I had a placeholder. 7 times 0 is 0. 7 times 5, that's 35. So usually write the 5 here. And we're going into the 100th place, and we have 3 here. 7 times 1 is 7 plus 3, that's 10. And so we're going to do a bit of adding. I put my plus sign right here. All right, let me put the plus right here. All right, so let's go. That now 10,500 plus 0 is or 10,500. So indeed, sir, you are correct. Now, we are trying to see if this total of 10,500 and 6,500 would give us what was collected. Let us do the computation. Let's add. So we have 6,500 plus 10,500. What's the total, students? You can
Go
type
ahead
it in the
and
chat.
type it in the chat. So. All right, so I'm seeing 17,500.
So we are seeing that a total here of 17,000. I'm putting in my...
I'm seeing 17,000. So let's check. I see, yes, I saw 17,500
Oh,
and I'm also seeing 17,000.
so you want me
And
to
I
do
think
the
the
addition?
17. Yes, you can.
All right, so let's place 6,500 on this side. And then I'm going to write my numbers accordingly. And we're going to do the addition. Student, this is how I expect to see you guys writing on your test paper, on the paper. It's your paper. We'll do the working so that we see the thinking. And we know that 0 plus 0 is 0. 0 plus 0 is 0. 5 plus 5 is 10. And so because of the base, we're going to have this 0 here and rename. And so 6 plus 1, that's 7. And 1 with nothing there, we get 17,000. So the total here is $17,000. My question, how much money was collected? Somebody can just unmute and tell us how much money was collected. So we did get the 135, that checklist is right. However, based on time, we were supposed to collect 15,000. However, we have 17,000 here. Now, I love the fact that we started at 65. Clearly, we realize though that some numbers need to change. What are some of the numbers that we would like to change? Are we going to adjust the 65 to get more adults being at the concert? Or are we going to adjust the 70 to get more students being at the concerts? Bearing in mind that it's $100 per student and $50 per adult. All right, so screenshot, write off what was here, but 65 and 70 is not an option. All right, so we are going to move on to the next slide because we have 2 other scenarios with the same problem.
And while
Right.
you move on, Miss Cameron, don't take this off the screen as yet.
Okay.
I want to, when I looked in the chat, I am seeing that person, I'm just thinking that persons might have done the addition in their head. And I'm
Right.
saying to you, we're teaching you strategies such as modeling, reasoning abstractly and quantitatively. It would be good, just like how you see Mrs. Cameron Edwards here, show her working on the screen, that you show your working. So as I said, when you model, you can always go back and check to see where you have gone wrong. Put it down so you can see your calculations and you can make the necessary adjustment. One digit that is incorrect makes the entire thing wrong. And we don't want that because you know what you're doing. All right, that's it.
Okay, Miss, thank you. So we're gonna move on. So I'm going to have to clear the screen. All right, so I love the fact that someone started with 65 and 70. That was a good thought. I don't know. The person who gave us that originally, what was their thinking? Did you guess and check? Why did you give us that number? Why didn't you start at 10? Why didn't you say to us 10 adults and 10 students? Why did you start there? What was it thinking? What was it thinking?
That person could just raise their hand. We will unmute you and let you share. Not sure who that person is. So I'm going to ask just that person to raise his or her hand.
Yeah, what was the strategy that you used to give us that 65 and 70?
So if you were that person who
Yes, the
gave us
person
that
who gave us.
answer,
I think it's T Brown. Go ahead, T Brown. Unmute and let us know.
all right, go ahead, T Brown.
T Brown, you were the one that gave us 65 and 70?
No, I'm not sure.
Okay.
Maybe it's Geneva. Geneva?
Go
Is
ahead,
it you?
Geneva. Geneva.
Yes, miss.
Was it
So
you who gave 60? What was that,
Yes,
miss?
miss.
All right, go ahead. Tell us what was your thinking.
why did you give us
Miss,
65 and 70?
miss, the student price are like lower than the adult price. So the adult will be the most, like the adult will be the most, and the children will be like a little bit less.
So you are saying you want to go up more with adults and less children. Okay. All
That's
right.
exactly it. Yes.
That's exactly it. All right, let's continue and see. All right, so we are using a table to identify patterns in doing our solution. All right, so let's look at this case. So based on what Geneva said, Geneva didn't agree with Sam. Sam came up with 90 students and 40 adults. So let's look at what Sam working. Sam worked the problem and got 90 times 100 is 9,000. And then 40 times multiplied by 150 is 6,000. And so Sam got $15,000 exactly. But what could be the error in Sam's thinking? Anybody could identify the error in Sam's thinking? He got the money, but what was missing? Anybody can type in the chat. What do you notice? He has 90 students and 40 adults. I'm seeing something in the
Miss
chat.
Williams from Reach Grade 5. Miss Williams, Reach Grade 5. Someone from that class could share.
Go ahead.
He didn't have all 135 tickets.
Excellent, excellent, excellent. So though the number, the amount is $15,000, what we are not seeing though is the number of tickets stubs. So 90 plus the 40 is 130. All right. So we just explained that he didn't meet that constraint. What about this case too? This is another Sam, or Sam went back to his seat and came up and said, okay, miss, I meet the constraint now. I have 135 ticket stubs. So I have 95 students, which is 9,500, because 95 multiplied by 100 is 9,500. and we have 40 adults at 150, that was $6,000. But what do we notice? What do we notice, students? It over the 15,000. So is Geneva right by saying we need more adults to get the 15,000? Or based on the pattern that we are seeing, what do you think? Right here, so we have 95 students and 40 adults. Do you think we need more adults or less adults? What say you? How do we get this number to be $15,000? What do you think we need to do, students? Type it in the chat, all right, on mute. I'm seeing some person raising their hands. Go ahead. What can we do to get 15,000? So we have the 135 here. We want to adjust the numbers somehow. We're very, very close in our students, very, very close.
Jamari Edwards, you may go ahead.
Go ahead, Jamari.
We should have to take off 5 more students from it.
Okay, 5 more and put the 5 where? So you are saying that I must take off 5 from this and put it back at 90, right? And you're saying I'm to increase this because the 5 have to go somewhere, you know. But remember now we're working with 135. So if I take it off there, so where I must put that 5? We have to account for 5 persons. Is it going to be adults? Is it cheaper or more expensive? What is the cost effectiveness? You know, let's think about it. Somebody else tell me if you agree with sir, this young man that says take off 5. And I'm thinking he's saying put the 5 over here. 45. Wait. He's saying to take it off and put it, and I don't have anywhere else but to put it after increase the number of adults.
All right, so Ailey, while Miss is writing that, you can go ahead. Ailey?
Haley, what are you saying?
All right, one more time. Ailey, you may unmute and share. Go ahead, Ailey. Not sure why we're not hearing her.
All right,
so let's move on to Christiane. Christiane?
Go ahead, Christiane.
Miss, I think that you should put it to the adult side because adults cost more money and you can get more money for the funds.
Okay, all right. So students, we are going to look at one last calculation with increasing that to see if that is better. All right, and then we go through some. So we're going to increase this by adding 5 to it. All right, and so let me ask a question. Adding 5 adults, 5 times 150. 5 times 150, let's look at that, because we're looking at whether or not we need to increase the adults or decrease the number of adults. So let's go. 5 times 150 is what? Students?
Come on, students, use up the chat. We see the answer coming in quicker. All right?
Use up the chat. What are we seeing in the chat? 5 times 150. 5 multiplied by 150.
Not seeing anything coming in as yet. Come on, grade 5. That's quick.
All right, let's look
right,
at.
I see 750.
All right, 750. And so students, remember we spoke about regularity and repeated reasoning because 1 times 150 is 150. And so 2 times 150 would be 300. All right. And right away, if I was to add another 150 to it, so we are able to, add another 150 or look at if I was to double this to get 4, what would I have and so forth. All right. So students, we're asking you to look at quickness in doing the problem. So 750 is correct. All right, so my question to you, if I was multiplying 5 times 100, that's the student. How much we are taking off? We're taking off 500. So you're taking off 500 out of this. So this is now 90. So we're left with 9,000. And we're going up by 5. So we're adding 750 to this. I want to ask a question. Are we getting closer to 15,000? No, 10 is extra. Are we getting closer or are we getting further away from this? So this is now 6,750. When we add 6,750 to 9,000, what are we seeing? I want us to see the pattern. 9,000 plus 6,000. And I'm going to ask you the question again. Do you think we need more adults? Or
Come on, guys.
So
Go ahead.
9,000 plus 6,750 will give us what? Tell us. So this is
Please
now what?
type it in the chat.
Type
Go
it
ahead.
in the chat.
Type it in the chat. I'm seeing 15,750 from
So
Amelia.
students, I am agreeing with Amelia. My question to you, when we increase the number of adults, remember we know the target was $15,000. They made 15,000. So the more adding more adults is pushing the costs or put the amount of money collected away from the $15,000 target. Are you seeing that, students? So let's ask the question again. Do you think we need more adults or more students to make us have that benchmark or to reach that 15,000? We were so close right here. When we had 95 students and 40 adults, we were so close, right? And now some students are saying to have less students and more adults. And by getting more adults, we realize that we're adding a whole $50 more. So for every adult, it's $50 more than adding a child. And we're going away from the targets. All right. I see many answers coming in the chat. Do you want us to reassign the numbers? Let's go. How would you want me to reassign? Please tell me. Students, we need to answer.
Yes, if you want to answer, please raise your hand or you can go ahead and type it in the chat. All right, so Latoya McDonald, unmute and speak. All right, Latoya, you ran away. Let's go to Marquise Myrie. Please unmute Marquise.
Miss, you would need less adults and more children.
Okay, so tell me what your combination will be. We had 100 and we had 95 there. Tell us what would we need to do. Do you want us to go up by what? Tell us what would we need to do.
Miss, the amount of students would go up by 9 and the amount of adults would go down by 6.
Okay.
No, not 6, 9.
9. So you are saying 31 and add 9 to the 95 or what?
90. Add 9 to 90.
So you're saying 99. Multiply that by 100. And we are left with 9,900.
And 34.
And you have 34. Okay, multiply that by 150. All right, this is not so easy a multiplication. Let's go. Let's see you quickly multiply 34 by 150 and tell me what you get. I'm going to erase down at the bottom while we would do that multiplication up the top. So he's saying add, it's 99 to 34. Just type it in the chat once you do the multiplication, students. I want to say something to us. When you're doing the problem, if they give you constraints, so we'll underline 15,000, we'll underline 135. So students, you have to bear that in mind when you're doing the problem. So let's go. What is 34 times 150 multiplied by 150? 34 multiplied by 150. Am I not seeing it in the chat?
34 multiplied by 150. Please check that answer again, Javika. 34 multiplied
Or
by
if I said to you earlier, we can put the 150 and write it like this, and let the 34 becomes the multiplier. Okay, this looks like a root, but it's a 1.
Okay, so I'm seeing quite a number of answers coming in saying 5,100.
Is that correct, Miss?
Yes, it is. Amelia, you're correct. Yes.
Okay, thank you, Amelia.
5,100.
So 5,100. All right, so we have 5,100. Don't mind the marking. Okay, so right away, I think something is still missing because 9 plus 1, that gives us 10. So I'm going to put my 2 zeros here and carry 1 here. This is let's see if this works out. Does this give us 135 though? No, this gives us 100. Let's go 9 and 4. That's what, 13.
And 9 and 4
So this
again.
is 133. This doesn't give us the combination. So even though this gives us 15,000, we don't have the 135. The 135 we are working with. So we're so close, students. So close. This is so close. What do we need to do now? We are short 2 students or 2 adults. Where do we put them? Where do we put them? And look at the answer that we have. We have 15,000 by having 99 students and 34 adults. Let's see how best we can, look at this combination again. What are you noticing? Are you noticing that when we add the adults, we're adding 150. However, when we are adding the students, it's only $100. What say you? So we are very, very close. All right, Miss, I think while they're still working and doing a bit of problem solving here, I can move to my table to see how I would have arranged my table, and then we can see what comes up. What's the discussion? All right, so I decided to organize the information in the form of a table. I started with 125 students and 10 adults. I'm just saying I'm starting with that number. Nobody decided to start there, but I decided to start with more students because when I look, if I was to flip this and have 125 adults, I would have too much money and I would exceed the $15,000. All right, so I noticed that my 125 and my 10 adults give us the constraint of 135, but I only got $14,000. I decided to take 10 students down and increase the number of adults by 10. What does that calculation look like? So 100 times 115 gave me 11,500, and I would have doubled my 15,000 to my 1,500, 1,500, and I would have gotten 3,000. Now, when I look at this total, I now have 11,500 plus $3,000. That's 14,500. I'm going to write where we left off. So we had 99 times 100 And we have 9,900. And then we had what we were told, what, 30, 31 or 30? What did they give us a while ago? It would be 33 or what number we had a while ago. I erased it, but I need to get 133. That much I know. We got 133. So I think this was 34. Let me just fix this. I think it was 34. Was it 34? 4, 9, and 4. That's 13, yes. And so when we multiplied this by 150, what did we get? I believe Mrs. Williams, he gave me this before. I don't remember, but I know at the end we got 15,000. But we didn't have the total.
Right, that is it. I think it
So
was
what was right here?
133.
But what was the value of 34 multiplied by 150?
I think it's 5,000. Let me make sure again.
5,100?
34 multiplied by 150. Yes, ma'am, 5,100.
Okay, awesome. So students, we have 115 here and 20 adults, and that is 4,500. So that's 500 short, the 15,000. Now we have 133 in total, which is 99 students and 34 adults, and we are dead on the mark, but we don't have the number of persons attending the concert. We don't have the total. What do you think we need to do now? We're trying to now come up with some generalization. We have seen some things, we have tried some guess and we have checked the guess. So we did some guess and check. We tried. We need to now narrow it down. So clearly having too many adults will push us too far to the right, and having too many children would push us far to the left. So I am now asking us, where do you think we should fall? And 99 is not it, and 34 is not it, 115 is not it, and 20 is not it. We need to try and narrow it down now so we can finish the table and go ahead. Go ahead, the students. I see 5 hands up.
So let's go to Ailey.
Okay.
Ailey, go ahead.
Bridget Walker sent me a message directly. Would you like to share your thinking, Bridget? I'm seeing Bridget sending me something, and I would like her to unmute.
Okay, let me get to Bridget. Bridget?
Excuse me, miss?
Go ahead
Bridget?
and share.
No, wait for Bridget. Go
Miss,
ahead, Bridget.
it would be...
All right, asking again for Bridget to unmute. Oh, Bridget Walker is unable to unmute because they have not joined with their microphone. Hence, you're getting their reply.
All
so,
right,
Bridget, if you're using a phone, please look for dial something of this sort. I don't remember dial what. That headset there, dial, and then you're going to select join with phone. Yes, go ahead. Bridget, you can unmute now. Bridget? All right. So while Bridget is unmuting, the person who is so eager to speak, go right ahead.
Okay, so it would be 105 children and 30 adults.
Can you tell us why? What's your thinking?
Because 105 times 100 is 500. And 30 times 150 is 500. And if you add those, you get 15,000.
All right, you're correct. That's exactly what Bridget texted in the chat. And so students, just to go through what we would have done, we had a problem. We know that we're working with a concert. We know how many persons attended the concert, which was 135, and we know how much money was collected. The question simply asks us to decide what the total how many of who was there, how many students were in attendance, how many adults. And so students, I am saying to us, the tasks are there, but you have to persevere, you have to break it apart and look at the target. I'm getting 1,500 or 15,000, sorry, but I'm not getting the 135, the 135. I have the 135, but I am not getting the $15,000. This was a great activity. We have only 2 more parts to go before we wrap up. And I know that time is running away from us, but this was a great discourse because I wanted to see how I spent the time working out the task, and it's the same way we're expecting you to work out the task. So let's go quickly. So Mrs. Blake, the principal, wants to surprise the students who participated in the fundraiser with tokens for their efforts. So the table indicates the total number of students in each class and the fraction the fraction of the class that participated in the fundraiser by purchasing concert tickets. Students, look for things like the word fraction comes out in this part. So you say, all right, fraction coming in this part now, expect to see fractions. Now, this is the rest of the question. And yes, it's going to be a mouthful. That's why I said 3 reads is important. So it goes, the total number of students enrolled at the school is 275. Given that the number of students who participated in the fundraiser from grade 5 is half the number of students who participated in grade 6, only 1/10 of the students from grades 1 to 3 had participated. And so you're asked now to calculate the number of students who participated in the concert fundraiser. Wow, wow, wow. Students, you're going to read a lot of things on the paper, whole heap. And so that's why I say to you, read once and read twice and read 3 times to pull out the information. So what information was given? Let's go through quickly. We know that it's 275 students enrolled at the school. The school have 275 students there. We were told that grade 5 is only half of the students from grade 5 because on the busier, so a study fail, PEP exam. So you couldn't go to the concert. So only half of the students in grade 5 participated to that of grade 6. So not everybody from grade 5 went, only half of the number that went from grade 6. It did not say half of the grade 6 class, no. It says half of the number of students who participated in grade 6. So whatever the grade 6 number is, only half of that for grade 5. And it also said only 1/10 of the students from grades 1 to 3 participated. So someone might ask, what when I say grade 4? Nothing was said right here about grade 4. Let's move on to the table. Do you see grade 4 in the table? Yes. They didn't ask us anything about grade 4 because grade 4 information was in the table. How many students we said? So let's go through the math that we need to solve the problem. They told us this. The number of students enrolled in the school was, type in the chat, how many students are enrolled in the school? How many students attend the school? 275. So I'm going to put 275 where the total is. Because let's go through the table. Where's my little pointer? The pointer told us the classes. So we have grade 6, grade 5, grade 4, grades 1 to 3. Number of students in the class for grade 6, 40. Only 25 students in grade 5, 30 students in grade 4. But guess what? It's 275 students in the school. Can you tell me how many students is in grade 1 to 3? Please tell me. How can I find out the number of students at the school and they're in grades 1 to 3? Tell me what's the number. I do not. Javier Harafa, type in the chat. A little birdie whisper and tell me that it's lunchtime now. I'm going to tell them, say, we're not going beyond lunchtime, so I don't have much time. It's because I was bumped from the internet. I'm bumped by the internet. I beg on like 10, 15 minutes more so they can have lunch. So, is it in the chat for me?
I'm seeing 275 and I'm seeing 180.
But we already know that 275 is all of the students in the school.
So I'm
So-
seeing 180 from Amelia.
So how did you get 180, Amelia? Tell us. Anybody else get 180?
Unmute now, Amelia, and share with Miss Cameron.
First, I added 40 plus 25 plus 30, which would be 95. Then I minused it from 275, which would be all of the students in the school. So then I got 180, and then I add 180 plus 95, which would equal to 275.
All right, you're correct. So let us say, right, what she said. She added the 40 and the 25 and the 30. And so she would have gotten 95, right? Let me do this. 25 and this is what? 55 plus, so she got 95. And then when she subtracted the 95 from the 275, she got 180. All right, that is correct. No, we have some things we want to fill in over here. So, because who remember when I said that we saw the word fractions coming up. All right, so let's go. Now, what is 0.25? It says the fraction of the class that participated. Right in the chat, Mr. Edwards. So half of the students from grade 4 participate. So what does half of 30 tell us? How many students from grade 4 participated? Type it in the chat. Miss, what do they have? So if I say half of the students at grade 4, half of 30. Miss James, you don't want to type in the chat. It's too lunch
Well, I'm
time.
not seeing anything. I'm seeing 15. 15?
Okay, yes, that is correct. All right. All right, so I did ask a question though. What is 0.25 as a fraction? The question said, what fraction participated? And they said 0.25 of grade 6 participated. What does that fraction tell me? What is that as a fraction? What is 0.25? Amelia?
So in the chat, Amelia is saying it's 1/4.
It's a quarter. All right. So therefore, students, you must be able to decontextualize and decompose the numbers in the question. So now the question didn't give you a fraction, but a decimal. But you know how to change from decimals to fractions. So let's look at this now. Right away, someone said a half. So let's come in with the 0.25. And it comes out, and yes, a quarter is correct. So my question, if a quarter of the students at grade 6 participated, how many students from grade 6 participated? Write it in the chat. Are those in the chat moving? I just see one person. Okay, I see 2 now. Waiting. Only 2 students. No man, 3. Okay. I want to see like 50. I want to see it blowing up.
Yeah, I'm seeing 10. I'm seeing 10. I'm also seeing 80. So we have 2 answers there to contend with.
Okay, let's ask the student that gave us 80 to explain the thinking. How did they get 80?
That's Danielle. Pauline.
Danielle, can you tell us how you got 80? If 80 is your final answer? Because we're looking at, please note, we're looking at a quarter of the students of grade 6. So we're looking at a quarter of 40 because there are only 40 students in the grade 6 class. Go ahead, Danielle.
Miss, grade 6 miss class is 40 and 40, 80 miss, and the half miss was the 4 and 4 miss, the 4, the 1, 4, the 4, and the other 4 I add, and then I put away the answer I get for the fraction, and then add the 40 and 40 miss.
So you're saying that is 80 students participated from grade 6. Don't
Yes,
move.
miss.
Keep. So let me ask a question. What's the total number of students in grade 6?
Total miss is 40.
40. All right,
Yes,
so
ma'am.
40 students in grade 6. I'm going to over here and I'm going to model using a rectangle. And because it says a quarter, I'm going to cut my rectangle into 4 parts. All right. Can you tell
Yes,
me
miss.
where to shade if I'm looking for a quarter? How many parts of the rectangle would I shade? 1, 2, 3,
One.
just 1 part. So I'm shading right here. And so students,
Yes,
you see,
miss.
understand why I say I would want us to model the math. So if the entire class is 40, how would I divide the 40 into 4 parts? Tell me.
Oh, we are going to divide 40 in 4 parts.
Mhm.
And how much would
Miss,
each part
And how much would each part be? So that I end up with a total of 40. What would come here, 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 here?
Miss, that put one more of the 4, and yeah, you add everything. You add
All right, let me
everything,
ask a
and then
question again. I have 40 and I'm going to divide that into 4. Or I'm sharing 40 with, or 40 things with 4 friends. How much of that would one person get?
4. No, miss. Times 2.
2. So if I add 2 plus 2 plus 2 plus 2 plus 2, would that give me 40? What is
No,
2
miss.
plus 2 plus 2 plus 2? What's
8,
that?
miss.
8.
Yes.
Okay, so it cannot be 2 plus 2 plus 2. What?
Miss, that be 8, miss. That be 8 plus 8 plus.
8 plus
Yes,
8
miss.
plus 8 plus 8.
6 times, miss. 8 6 times.
But it's 4 persons I'm sharing it with, so
Oh,
it
miss.
can't be 6. All right, take your time, take your time. You have
and while
$40.
uh-huh.
You have $40. And you have 4, you and your 3 friends, 4 of you want to share $40. You want to go
Yes, miss.
outside to buy some sweetie. How much money would each of you get? It's $40 they have in total. It's not more than 40. It's 40 you
Miss,
have.
how much friends?
It's you and your
4
3
friends?
friends. No, including you?
Yes, miss.
Including you, it's 4 of you.
Yes, miss. Miss, $10, I give them, miss.
$10. So let's go again. So if 40 students in the class, and if I'm going to use
Yes,
a
miss.
model to represent the 40, and you told me that a quarter, I'm supposed to shade just 1 part. That means in 1 part, we'll have 10 students. Another part will have 10 students. Another part will have 10 students. And another part will have 10 students. 10 plus 10 plus 10 plus 10 gives us 40. I'm asking you, what is a quarter of the class? The quarter of the class that is shaded. How many students is in the shaded part?
Shaded part.
These are the
1.
shaded. Hold on,
10,
hold on.
miss.
10, exactly. So if I was to erase the shaded part here and put the numbers inside, there would only be 10. And where's my eraser? Let's go back to my eraser. And students, I'm taking my time to just make sure. I know some answers came in the chat. So only 10 students out of the 40 students participated in the concert. So I put in my 10 right here. You understand what the question is saying now? So it says
Yes,
40
ma'am.
students in the class and only a quarter of that 40 participated in the concert. So it's only 10 students. You shaded this to show me what a quarter was. You told me that a quarter would be 1 part of the 4 parts. All right. So students, we're not going to go any further with this. So it's okay. So Sir just brought me to my answer. Many of you gave me the 10 already, but I just wanted to hear him go through the process to get the 10. My question to you, sir, do not come off yet. Only half of the students of the total that attended for grade 6 attended for grade 5. Listen to what I'm saying.
Yes,
Only
miss.
half, the number of students. So 10 students from grade 6 went to the concert. Only half of the number of students for grade 6 went for grade 5. Only half. How
Yes,
many
miss.
students from grade 5 went?
Went.
Let me go again. Let me break it down. From grade 6, how many went from grade 6? So we're talking about this right over here. How many went from grade 6? How many students participated? You're telling me a different answer. Which answer you're telling
Oh,
me?
miss, 10, miss, 10, no.
10, right. So 10 participated from grade 6.
Yes,
For
miss.
grade 5, half the number for grade 6 participated for grade 5. How many students participated from grade 5? Only half of the number. So the number that participated grade 5 is half that of grade 6. Can you tell me, type
Yes,
it in the
miss.
chat, how many students participated from grade 5?
From grade 5, grade 5, 20, 13.
Think about it. Think about it. You can mute while I take somebody else's hand, and I'm going to also erase what we have here. Bear with us, teachers and students. We just need to make sure that the students are making sense of the task. Anybody else want to share in the chat? You can go ahead and share now. So we brought in our 10. And so I'm now putting something on the screen. It says the number of grade 5 students who participated.
One over.
It should be half the number. It shouldn't be in, but should be half the number of students who participated in grade 6. So my question to you, how many students now participated in grade 5? Can you put it in the chat? And Mrs. Williams, you can go ahead and tell me. Mrs. Williams?
I'm right here. I'm checking the chat just now. I'm
Okay.
seeing Tijon Saunders and John
Right.
Mills saying 5. John Mills is also saying 5. Tavares Garden is saying 5. Quite a
Okay.
number of responses saying 5.
All right. So,
Miss?
yes.
Miss 12?
And
12 and a half?
Okay, how did we get 12 and a half now? You're going to talk me through the 12 and a half. Or what I'm going to have Mrs. Williams.
Yes, my dear.
I was trying to see how you could take him one away to break it down, but let's go through the half. I'm trying to
all right, Miss.
Bring in some things, yes.
Miss, the one with what left, Miss? Miss, remember 25, Miss, yes, Miss? 12,
Yes.
12, Miss, and then you say the one, what going to left back? You say just call it off, you say 12. You say 12 and a half.
Okay, so I didn't say half the students of grade 5 though, but listen to what I said. I said right over here, so where there is 10 students from grade 6. So listen to this now. 10 students from grade 6. Hold on, listen. 10 students from grade 6 participated. Only 10 out of the 40. However, for grade 5, half of the students, with half the number of grade 6 students is, so let me say it this way. So half the number of grade 5 students or grade 6. All right, let me write something here. I want you to see what I'm saying. Let me go back to my pen. So we have 10 students in grade 6. So grade 6 have 10 students. Grade 5 is half the number of students in grade 6. So we're finding a half of the number. Yes, I'm listening. I'm waiting on you. No. I don't want it to be multiplying anything. I just wanted to stop, pause, and wait. Listen to what I'm saying. Only 10 students from grade 6 participated. For grade 5, for your grade 5, only half of that 10 participated, how many grade 5 students participate? So we're trying to find a half of 10.
5.
Thank you. So it's only 5 students participated from grade 5. So even though the class was 25, only 5 students alone participated. All right. Now I want to
miss.
ask another question. So you can go ahead and mute now. So thank you very much. And I want you to raise your hand again if you need us to take you through something else. All right. And I
Yes,
want you to
miss.
private message me, Mrs. Williams, to take his name privately. Text Mrs. Faithlyn Williams privately. Give her
Is
your
that
name.
Danielle? Danielle?
Yes, miss.
I'm going to send you an invite. Please take it when I do. All right?
And
When
then
you
you're
see.
going to send
Yes,
her
miss.
your name and your school. Okay? We want to reach out to
Yes,
you. All right, Danielle. Don't send it in the general group now, you just want to send it to Mrs. Williams by herself. All right, so let's move on to what we have. So indeed, that is correct. All right, so the number of grade 5 students who participated is half the number of the grade 6 students who participated. So that's 5. I now want us to complete the table. And remember, we're looking for fraction. And what did I do? I wrote the 5. Let me go back to my pointer. As a fraction to the whole, which is 25. So that's 1/5. So only 1/5. You can go ahead and mute him, Mrs. Williams. All right. So she's taking you to a room, and you're gonna talk with her in the room, okay? All right. So 5 out of the total, the whole 25 was 1/5. All right. And we already worked out that a half of the 30 hold on. All right. And so we wanted you to also see that 1/5 as a decimal is 0.2. So teachers want them to get to a point where they can flexible work between decimals and fractions. So that's what the task didn't ask for that. We just decided to engage them so that they would see how we can change or convert from a decimal to the fraction and vice versa. So 0.5 of 30 or a half of 30 is 15. The final part to the task says only 1/10 of the students from grades 1 to 3 actually participated. And so we decided to write that as a fraction, 1/10. I didn't write it as 0. I didn't write it as 0.1. I just left it as a fraction. And so that would have allowed us to have 18 students, and the total number of students that participated in the fundraiser was 48. Not just attending the concert, but participated in the planning and everything. Now, the final part, which is not a big part, only one breakout room is created for the student that we are assisting. And I know the numbers are dropping. We only have one more part to the task, and it says, just a token, Mrs. Blake, the principal has $10,000 to buy tokens for all the students who participated in the fundraiser. Each token costs $250. However, it's cheaper to buy tokens in the dozen, costing $200 per dozen. Is it possible for her to buy enough tokens for the students justify? How many students? We just wrote that 48 students, sorry. Looking for my pointer, right? My laser pointer, not my pointer, I want my pen. So we were told that 48 students actually participated in getting everything done. So the principal wants to award them with a token. However, each token costs $250. And so we want to know if she has sufficient money. And this is all this task is asking us for. What problem solving strategy would we use to find out whether or not it's cheaper to buy it by the dozen or to buy it each individually for 250. All right, I'm giving you 2 minutes. This is a very, very final task. And then we will just bid you all a good rest of the day. So don't leave yet. Do not leave. All right, so what information are we given? We are given $10,000 the principal has to spend. Each token costs $250. And if the principal was to buy it in dozen, it's cheaper. It costs $200. You are to tell us which one you would go with. All right, so let's go. We have these two things. Let's take some combinations. All right, I would like you to tell me which one you think is cheaper. Miss, why some students are messaging me directly? They can't type in the chat. Miss the dozen. Okay, Joshua, how did you get the dozen? Wanna tell us? Some persons are saying yes, they would multiply. All right, I'm seeing some answers coming to me privately. And so this is one of the response. One student said, that they would choose the operation strategy. And so they would multiply 48 by 250, but they would get 12,000. But guess what? 12,000 is more than what the principal budgeted for. And so 2 persons in the chat messaged me to say they would go by the dozen. And so by doing each at a dozen, how many dozens would the principal need? And that is 4 dozen. All right. So when we add or when we multiply 12 by 200, we got 2,400. And when we add 2,400, or we could have multiplied 2,400 by 4, we would have received, gotten 9,600. Go ahead, Geneva, and you raise your hand. And this is the final question. Let's hear your thoughts. Mrs. Williams is helping the young man in
Geneva,
another
go
room.
ahead.
Go ahead.
I must point out to you, Mrs. Cameron Edwards, Daniel seemed to have joined as a class. And so the others would miss the session if he actually accept the invitation to join. So I understand why he's still in the main session.
Okay, that's a problem.
Okay.
Go ahead, Geneva.
So means since each token costs the $250, the cost per dozen is $200, and the cost of 4 dozens equal $240 plus for $240 plus $240 plus $200 equal 900.
No, not 240, 2,400.
Yes.
Okay, got you. 2,400 is the correct thing.
So miss the cost of all of these. Cost of the 4 dozen is it's 9,600.
Awesome. Excellent, students. And so right there, we would have come to the end of taking you through just as a task, a performance task with multiple parts. Yes, go ahead.
What time would we come back?
Oh, this is where the session ends for today. I'm not sure if your individual schools will be doing something else with you. All right. So I just want to thank all the students who came on today. And we just want to say to you, remember all that was shared from the start of the session. We took you to the different practices, which took you through the ways to express your answers, how to communicate, how the models can help you, how to be precise. And we would have included all of that in a task, a fundraising activity. Students, yes, you're going to get a problem-solving task. Read the task over. Look at the context of the task. The context of today's task was a fundraiser concerts. And so in the task itself, we had to do some combination. We had to do a bit of guess and check. We tried to use the table and pattern to place our information in an organized manner. And when we're through with that, we were also given some fractions to compute. Don't become overwhelmed. Take each part bit by bit. Understand the math in the problem, show your thinking, show your working, and you will be successful. All right? And so if there are no questions, I see some persons typing in the chat. At this time, we would want to say to you, thanks for joining us. Those who joined us on YouTube, thank you very much for joining us today. The session will be repeated tomorrow. You don't have to join the session again tomorrow because we'll be covering the same material. All right? So do enjoy the rest of your day. Mrs. Williams, is there anything you want to